Welcome to the webinar about industrial IoT and the KEB NOAA platform, which is Next Open Automation. First, Daniel will give you a rundown of what will happen in the complete webinar.
Yeah, thank you, Johannes. So this webinar series basically consists of 4 single webinars. And in the first one, we're going to give you a brief introduction to IIoT. We are going to explain some common terms that you will hear throughout the series. So it makes sense to explain this in the first place. And also we're going to give you an overview of how we are going to use IIoT at KEB and explain, as Johannes said, our next open automation or NOAA system, and what the USPs of this IIoT platform is. In the second webinar, we're going to give you an overview of the core features of NOAA and how we are going to use them to increase the value of machines and basically add some digital features to those machines. And in the third webinar, we are going to show you how you can easily transfer data of your machines via our NOAA Edge devices to the cloud and create some dashboards there. One use case for that would be, for example, condition monitoring. And in the last webinar, Johannes is going to show you how you can easily create HMIs for your machines using our Helio app.
In the first webinar, this will be an overview. We give you examples, and if you're from management, just watch this video. Afterwards, it will become more and more technical. So if you're interested in going deep into what and how you can do things with the Next Open Automation, the NOAA platform by KEB, watch the other 3 as well. But first things first, let us present ourselves. This is Daniel Preuss, product owner of the IoT platform, or more specifically, NOAA Portal, which lives in the cloud. And we will give you in the video the details about telephone and email. And then you present myself.
Then we have also Johannes Schäfer. He's the product owner HMI and an UX engineer. And he is the product owner of NOAA Core. This is basically the software that runs on our NOAA Edge devices. And what an Edge device is, we're going to tell you in a minute.
So we have this out of the way. Let's tell you about the Internet of Things, the Industrial Internet of Things, to be more specific, IIoT. And if we refer to IoT or these kind of things afterwards, this makes it easier for us. So what is IoT?
Yeah, good question. I think there are lots of definitions when you look through the literature on what IIoT exactly is. I think it's best to maybe explain it a little more hands-on. And I understand IoT as you are able to connect your industrial devices. For example, your machines, your PLCs, so your logic controllers, sensors or instruments, like for example for measurements and so on, to computers. And use their computing possibilities to generate some extra value. For example, you can create new logics that you embed in your automation system, and therefore create new use cases for your machines at some additional value. Typical use cases are, for example, as I already said, condition monitoring. So you are able to monitor your machines, collect some values of certain process parameters and so on. And you can see when something is going wrong with your machine. For example, anomaly detection is one of those use cases as well. Or a completely different one would be fleet management. So you are able to manage the software that runs on your computers via the cloud, and you don't have to run with an USB stick to your to every single device and plug it in to update software and so on. So there are lots of quality of life features as well that you can use. And to summarize it, you can collect, exchange, visualize, and analyze the data that you collect from machines. And
what is important that this happens in an industrial setting. This is the first I in IIoT. This is not home automation or smart homes, whatever, but we are talking about machines and controllers and a production line or a complete factory or plant where you collect that data, you visualize it, and you analyze it to improve productivity, either for machines or your complete production line or plant fabrication, and the efficiency as well. And now may have some examples.
Yeah, exactly. I think it's a good time to maybe go through an example and deep dive a little more into the world of IIoT and give some more hands-on examples on what that exactly is. So, as I already told you, we have at KAB our high bay storage system. So you can imagine it, like a huge storage where there are 5 aisles. Each one has a crane to store and retrieve goods that you want to store. For example, we use it for our production at KAB. For example, for our inverters or our brakes and clutches. And each crane has 4 motors and which are connected to drives and a logic controller. And the motors, they create the movement for the machines. Yeah, that's a good visualization. And we have some horizontal, vertical movement, and to store and retrieve, like push and pull, and the motors recover on their way down. And basically, what we use IIoT technology for, like our NOAA system, is in the end to minimize the energy usage by analyzing the data that we collect from the usage of the high bay storage system.
If we're gonna store our goods, where do we place them? More to the front or more to the back, and how high, and so on, so that we get an overall high frequency of input-output, or less movements and then less energy usage. So let's be more concrete with this high bay storage system. What are the concrete steps to make this work? To connect this back to the terms that we defined in the beginning. So we connect all the devices that we have, like motors and PLCs, to one common bus to make it accessible on NOAA Core, which is part of the NOAA platform that runs on the edge. So we have all the data available, and we can access that data from different tools. For example, send it as telemetrics data to NOAA Portal into the cloud. There we visualize this data and calculate some additional logic and statistics on it so that we can inspect everything and draw our conclusions. And on the other hand, we employ some machine learning models to help us understand and make better use of this data and relate it maybe to energy usage or frequency of storage. So, and these will be our next steps. We've implemented everything in our high bay storage system already, and now we're looking at the data, inspecting that data, and analyzing it to reduce the energy usage of the total system.
Okay, yeah, that I think is a good explanation. Maybe we go a little bit more into detail and look at the topology in this slide. And as we explained, maybe we start on the left side. There you can see a nice picture of our high bay storage with very blue sky. And on the middle we see the message bus. And the message bus is basically where our NOAA software connects all of the apps that run on these edge devices, or like the small computers, the embedded computers, better term. And there you can see that all of these apps connect there together, and those small boxes here are those apps. And we have different apps installed. For example, we have the Codesys communication app. This app allows to the communication transfer data between drives and the message bus. So we are able to read those data from the drives. There are also other data from the drives, like the box right next to it. There's some high-speed data that we store differently. So it's we use a different app for that. And we have the condition monitoring app, which is which allows us to write data locally to a data storage, which is an influx writer, and we use a Grafana panel to visualize data locally on the edge. So this is all on premise. And we also have the cloud connector. This allows us to transfer data from the edge devices to the NOAA cloud and enable other use cases there. And maybe, Johannes, you want to explain the terms there.
Yep, so we promised you to explain some of the terms that we use inside NOAA and in IIoT especially. So if we start on the right-hand side, there is the edge device, and this hosts our NOAA Core software system, which basically is some kind of operation system for an edge device. This could be a small controller like depicted here, or an industrial PC, or wherever NOAA runs on. We will see that it is hardware independent. Main component of this is the NOAA data access, which means this is the common bus where all of the data will be collected. So we have that common interface in the middle where everything else connects. And as Daniel already pointed out, we have the different apps that we can install either from our app catalog or as custom apps with some custom logic. And for the high-bay storage system, we use both of this. So the communication apps, there is a standard communication to Codesys, which connects to our controllers. And we see here a C6 Smart device, which is in fact on each of the cranes. And then there is a custom app like the high-speed data transfer that we use to store locally and analyze with machine learning. And the lower bottom, we have the devices that we always talk about, like the controller, the drive, and the motor that control each of the cranes. A little bit to the right, we see there is a database which is provided from condition monitoring as a local storage. So here we have custom apps as a business logic. So what we do here is calculate statistics over the energy usage, etc. And we also, connecting that line to the common bus, provide this data back to the bus so everybody can access it. Via the cloud connector, we send data to the upper right corner, which is the NOAA portal that lives in the cloud, where we can visualize data, analyze data, and see what is going on actually live in the high-bay storage system, and calculate data and statistics, etc. on it to improve the overall process. So what we say, and this is in the upper left corner with the NOAA logo, this is our, how do we call it, platform?
Yeah,
Automation Platform as a Service, APaaS. So this is NOAA as a platform and a toolbox where you can choose the components that you need and deploy for your project, may it be standard apps or custom apps to realize your IoT solution.
So we are in the NOAA portal. Johannes already told you about that we use NOAA portal for different use cases that you are able to utilize in the cloud. And for example, we have the asset management. The first question is, what is an asset? So an asset is basically an item of value to a company. This can be a machine, this can be a factory hall, very different things, very broad spectrum. We are basically, most of the time, we are using it to refer to machines in production.
Just let me add here, in that map we see two locations of one company. That company is a fictional recycling company, and it has locations in Munich, and the other one is Düsseldorf?
Yeah, I think Düsseldorf.
Düsseldorf. Yeah. And below these two locations you find more assets, like that first shredder. Going one step deeper would be the fleet.
Yeah. In the fleet is basically your whole composition of all of your edge devices that you have in the field. So in your production hall, for example, and that are connected to your machines, and where our NOA core system runs on, and that is sending data to the NOA portal, so the NOA cloud, and via the fleet management feature, you are able to manage all of your edge devices from the cloud. So that means that you can deploy apps, as we already talked about what apps are. For example, the code-assist communication on the logic controllers for the high-bay storage system, which you just saw a couple minutes ago. And there you can deploy those apps on the machines. You can update them, you can delete them. Also, you can choose all of the telemetry data that is transferred to the cloud. For example, the efficiency metrics that we calculated in the high-bay storage system. There you can subscribe to them for all of the devices, and select which kind of data you want to transfer to the cloud. And exactly.
Yeah, additionally to the standard apps that we provide and that you have seen, you can add custom apps per tenant. So if you have some special logic, some database where you want to store your data, your local data externally, you can configure these apps here and deploy them. Everything is based on a microservice architecture, so these will be deployed as single services and Docker containers to the edge and run there and do their specific purpose. For the condition monitoring, you mentioned quite a lot already. We can show for one asset different statistics from one or multiple devices to get an overview of uptime, downtimes, or performance, energy consumption, and the like. And if you want to, you can also employ an alarming scheme. So if there is some threshold passed, you can send out an alarm either by email, Teams message, or SMS, and you can configure this to use it as a predictive maintenance means, so you can send out somebody to do a service before there is a downtime at the machine. So by now you should have gotten a good understanding of what IoT is and what are the challenges, especially for small and medium-sized companies, and what IoT can do for you and specifically with the NOA platform, so that you can deploy this readily. We provide NOA as a platform, as a toolbox where you can choose from, and you're free to choose the elements that you like and that you need for your solution. Of course, KEB supports you here as a full service provider, from whatever goes on at your machine into the cloud and whatever applications and analysis you want to do there. Let us now dive a little bit into the USPs of NOA, so that you sum it up a little bit surrounding our example and showing you what you have when you opt for the next open automation platform by KEB. So we have had a look at the high-bay storage system, where we connected all the different devices and assets, if you like to one common bus. And this is NOA Core on the edge. This is our hardware-independent infrastructure that runs on an actual edge device. And hardware-independent means we only assume Linux and Docker as prerequisites. Otherwise, you're free to choose your own hardware, or you can pick one of the options that KEB offers.
Yeah, exactly. Another USP of NOA is our, I would call it a unique app portfolio. So we have some standard apps that we as KEB provide for use cases. For example, we have the lots of communication apps, like our Codesys communication that we showed you in the high-bay storage system. Also, UPC UA communication that you also provide as KEB. We have the condition monitoring apps that we already showed you.
One of our fantastic apps is Helio as a development environment for industrial HMIs, which means interactive visualizations at the machine, to operate the machine, to set parameters, start processes, etc., which will be covered in more depth in video 4.
Yeah, we also have the vibration data analysis. Basically, you are able to place sensors on your machines, like for example a motor, and collect the vibration data of the motor, and you are able to detect anomalies that way in a running process. So based on this vibration data and a machine model, learning model that is running in the background, you are able to detect those kinds of anomalies, and then you are able to react accordingly based on the status of the machine. Also, our alarming helps you there, because you will get some messages via some third-party channels that will tell you when an anomaly is happening. This is like the KEB apps, but you're also able to, and this is something which I would say makes NOA highly customizable, that you are able to also deploy your own custom apps to all of your edge devices where NOA Core runs. And it's a great feature because you can upload your custom apps as Docker images on the NOA portal, and there you are able to deploy it to your edge devices. So that means that all of your logics that you wrote on your own, you can upload it to the NOA portal and then send it to all of the edge devices. You can deploy them there, you can manage it there, you can update it, delete it. Yeah, it's very flexible in that regard.
So that highly customizable means all the apps send and read their data from the common bus, from the NOA data access layer. So they have access to the same data structures and they write them back, so every app can profit from some calculations that you do in a custom app. Now it's portal time with the dashboards.
Yeah, so the data that is collected locally on the message bus is transferred via our cloud connector to the NOA portal. And there you are able to, in the device management, you are able to select all of the data that is transferred to the cloud and subscribe it, and generate some panels for it to visualize the data. And we have a low-code app builder, so you are able to use that data and build condition monitoring apps for it. So you can create your own dashboards based on your needs and customize it. And you don't have to be able to program it to get a nice looking solution.
So basically that means, and Daniel will show you this in video 3, you select the data that you want to collect from the edge device in the NOA portal, and with a one-click solution, which means one checkbox, you can create a panel and a visualization on a dashboard for exactly this data.
Yeah, exactly. That's a good point. the third video is planned for about 50 minutes, but I think we will be way faster than that because it's actually very easy to generate those dashboards in the cloud, and you will see how easy it is to collect all of your data there.
Yeah, we already talked about the tenant and fleet management, and with this you can deploy either standard apps or custom apps. We've talked about this as well, which gives you unprecedented customizability and flexibility in deploying NOA as a platform service. We also have that part where you can create subtenants, and Daniel explains you what this means for OEM business.
Yeah, as an OEM, you are able to use NOA Portal and the tenant management system to provide tenants for your customers. So, for example, when you are building a machine and you want to use our open automation platform to add some additional value to your machine, like for example the condition monitoring, and then you are able to provide a tenant to your customer where he is able to transfer the data to the cloud from there and use all of the features of NOA Portal, for example the fleet management as well, or the app catalog for managing and uploading custom apps. And there you are able to also see what kinds of actions the customer does and how many devices are in the tenant and so on.
Okay, one of the use cases that comes to my mind is if you rented out machines as of now on a daily basis, you can only charge your customers you have used it for 5 days. If you want to be more fine granular, you can calculate with new sensors and integrating that data based, for example, on the cubic meters of rubble that you pumped out or transported somewhere. So you have a better understanding of your what your customers do. You can recalculate your business and create a new business model based on volume and not just on days. For that customer renting out that machine, it will be fully transparent because he can access the data he has used and which costs this will incur, and you can calculate your costs and tariffs based on this data, collecting that summed up information and providing a bill accordingly. So with NOA Portal and the full NOA platform solution, you get a means to build out your business models in different ways or even create new business models. To sum it up?
Yeah, I think that's a good explanation. Basically, you are able to deploy new digital business models using our NOA platform, and use NOA as an automation platform for your customers and provide new values to your machines.
We hope you got a good picture about IoT by now, and what we want to stress is that with KUB you get a support from a really experienced solution provider.
Yeah, absolutely. So we are also able to assist you in realizing your IIoT use case. So we offer not only the NOA Core and the NOA system as a whole as a product, but we are also able to, we have some development capacities, so we are able to realize your IIoT use case from start to finish. And not only do we have that, we also have a hardware portfolio to support all of your needs.
Starting from the hardware, KUB provides brakes and clutches, motors, drives, controllers to control your machine, to operate your machine. We add on top of this Helio as a really powerful web-based HMI development tool, and from there you can visualize your machine. You can do a local condition monitoring to get and visualize data at your machine level. NOA as a portal or the core on the edge device itself binds it all together, and then we continue into the cloud with condition monitoring not only for one machine but for your complete production process. into device, asset and fleet management in the cloud, where you can have all of this and a alarming solution that is triggered by the cloud. Now we got everything explained and covered in theoretical terms and by example with our HiBase storage system. We thank you for your attention and want to welcome you to the next video, which is mainly Daniel's video and the video afterwards, and the fourth video in this installment will be about Helio, where I will be your main host.
Yeah, thank you. Yeah, thank you for listening, and we'll see you in the next webinar.